In this final video for this chapter, we'll turn our LED into something that can blink. So I'm going to introduce a new state, and this state's going to be the LED state. This will be analogous to this part of the diagram on the right-hand side. We already have a state for our WebSocket, which can be in a disabled or enabled state. Now we'll put our LED in an on or an off state. Again, this isn't strictly necessary to go to this much structure, but in the long run it'll be helpful to just to get this pattern down and continually stick to it. Just like we have our heartbeat state, we will have our LED state. And we'll start it as off. Just like our heartbeat has an interval, we're going to have a blink interval. So this will go on and off every quarter of a second. We shouldn't need to touch our event handler. All it does is put something in the enabled or disabled state, and we're just going to use that functionality. Here at the bottom of the main function, we need to make sure that our LED pin is set up properly. So in this case, that means that we will put it into the output state, meaning we're going to drive the output, not read it as an input. And we're going to put the built-in LED, and we're going to start it out in the off state. One small thing you might notice about the LED on this board is that the off state corresponds to a high output, and an on state corresponds to a low output. If you're ever curious where one of these variables comes from, you can always right-click, go to definition, and you can see that high is defined as 1 and low is defined as 0. Most boards will have this in the opposite direction, which means when you drive a pin high, it'll turn it on. Just slightly different logic for this one. It's probably using a pull-down resistor. Last thing to do is something in our loop here. So again, we want to make sure we're not ever calling delay. So our functionality here instead is to first check to see if we're enabled, and if we're not enabled, immediately just turn the LED off. That corresponds to this branch here. If we are enabled, that's where we go into our blinking state, and this is the code that handles blinking. So again, we get the current time. We see if we've passed our blink interval. If we have, then we change our state. If it's currently on, then we set it to off. If it's currently off, we set it to on, and then we update the actual state of the pin. And that's the pattern that you'll see throughout the rest of the semester. We introduce some idea of state, we initialize our state, we set our update timing, we set up the functionality, and then in our loop, we check to see if it's enabled, and then do something on some sort of regular interval. For example, reading from a sensor value or updating the motor's output. But all that's left in this video is to see if this actually uploads. The program compiled and uploaded, our board initialized, and it's ready for us to start sending messages. The LED on this board is right here next to the USB connector. I hope that'll show up in the video. If it doesn't, I'll zoom in. I can test this using WSCAT again. And it looks like I misspelled it. And that did. The LED started flashing. A more reliable way to test this, though, is to use an HTML file that I'm going to provide for everyone. This should look somewhat familiar. It's a similar interface that we've had before. And I'll grab out the IP address and port. Make sure the interval is below that's defined in the Arduino sketch, and connect. And the important thing to check here is that the LED is flashing. And it should turn off if I click disconnect. And it does. And I could try other things, like cranking this up, and we would notice that it would go into a flashing state for a second and then turn off. But I'll leave that to you to explore as part of your exercise.